Welcome back to the deep dive. It is good to have you here. You know, when we usually talk about logistics, the mental image is immediate and very loud.
Yeah.
People picture forklifts reversing, wooden pallets being smashed around, maybe a guy in a high-vis vest shouting orders over the noise of a conveyor belt. It feels very physical.
It feels like sweat and gears.
Exactly. Feels like sweat and gears. But today, we are going to flip that image on its head. We're stripping all of that away. We are diving into the brain behind the brawn.
The central nervous system.
We are looking at the silent, invisible layer that dictates every single move that happens on that concrete floor. We're talking about SAP Extended Warehouse Management, or EWM.
Exactly. And to be even more specific, we aren't just looking at the software as a tool you click through. We're looking at it as the central nervous system of a company's supply chain.
Right.
Because you can have the most expensive, high-tech forklifts in the world, but if the signal from the brain doesn't reach the hand, nothing moves.
Or worse.
Or worse, the hand moves, but it grabs the wrong box and ships it to the wrong continent.
That is a terrifying thought, and that really sets the stage for today. We are working off a really dense, fascinating technical training session O2 specifically, that focuses on deployment options.
It's a great source,
Yeah.
very technical, but the concepts are fundamental.
And the core tension here, the thing that I think is going to surprise a lot of people, is the problem of communication. How do different digital brains talk to each other? Because as we're going to find out, even when software lives in the exact same server box, it doesn't necessarily mean it gets along with its roommates.
It's a classic case of proximity not equaling connectivity. We look at the transition from the old world of decentralized systems to the new world of embedded S/4HANA.
Okay.
And the twist, and there's always a twist in enterprise software, is that the new world is essentially just the old world wearing a disguise.
I love that. The ghost in the machine.
That is exactly what it is. The legacy architecture is still there, haunting the new setup.
So, our mission today is to decode the invisible wiring. We're going to talk about logical systems. We're going to talk about something with the incredibly unfortunate name of the dummy logical system.
Which is not as dumb as it sounds, I promise.
I hope not. And we're going to look at the hidden switches that make the whole thing run.
It's a journey into the plumbing. It's not sexy, but if you get it wrong, the house floods.
Okay, let's start with the basics of identity. If you are a piece of software, before you can send a command to move a box, you need to know who you are, and you need to know who is listening to you. In the source material, they introduced this concept of the business system group, or BSG.
Right, the BSG. It sounds like a generic corporate acronym, doesn't it?
It sounds like a pop band from the 90s.
It does, but in the SAP world, let's imagine the BSG as a traffic cop. Or maybe a better analogy is the contact list in your phone. Its entire job is to exist at the EWM level, the warehouse level, and answer one fundamental question. Who am I talking to?
And when you say who, you mean the boss, right? The system sending the orders.
Correct. The warehouse is just the execution arm. It's the hands and feet. The brain trust is the ERP, the Enterprise Resource Planning System.
That's where finance lives, sales orders.
Exactly. That's where the sales orders are generated, where the money is tracked. The BSG tells the warehouse, you are connected to this specific ERP, and crucially, is this an SAP system or is it something else? It's the first point of identification.
Okay, let's unpack the scenarios the source material gave us, because this is where the complexity starts to creep in. Scenario A is the happy path.
The simple life.
You have one ERP system and one EWM system, just a one-to-one relationship.
In that case, the configuration is trivial. I mean, it's about as simple as it gets. You essentially assign the same business system group to both.
So they're in the same family?
No interference, clear communication. One BSG is enough. It's a closed loop.
That makes sense. But then we get to scenario B, and this is where the real world gets messy. The source describes a setup where you have one massive EWM system, but it's managing the logistics for multiple ERP systems, say ERP1, ERP2, and ERP3.
This is a very common scenario for large conglomerates. Imagine a holding company that acquires a pharmaceutical firm, an automotive parts company, and a retail chain.
All with their own legacy systems.
Each of those companies comes with their own legacy ERP system. They have their own finance departments, their own history, their own way of numbering products. But the parent company wants to save money, so they build one giant central warehouse to serve all three.
So you have three different brains, ERP 1, 2, and 3, all screaming orders at the same warehouse system.
Precisely. And this poses a massive data integrity risk. That's a huge problem. Imagine ERP-1 sends an order with the ID number 1000, and ERP-2 also sends an order with the ID number 1000.
Oh, okay.
If the warehouse just sees order 1000, it's going to get confused. It creates a collision. You might end up shipping the car parts to the pharmacy customer.
Which is a disaster. So in that case, how many business system groups do you need to prevent that collision?
You might think 3, right? 1 for each ERP. It seems logical.
I would assume 3. Channel 1, Channel 2, Channel 3. Nice and separate.
But the answer is 4.
4? Why 4? Where does the fourth one come from?
This is a nuanced detail that really trips people up during implementation. It's a classic consultant question. You need one for ERP-1, one for ERP-2, and one for ERP-3. That part's intuitive. But you also need a separate individual identity for the EWM system itself.
Why does the EWM need its own specific group in this scenario, but not the first one? What's different?
Because in the first scenario, the EWM is dedicated. It's monogamous. It belongs to that one ERP, so it can share the identity. It's just an extension of that ERP.
It's on the same team.
Exactly. But in the complex scenario, the EWM is playing the field. It's not dedicated to a single ERP. Therefore, it needs to establish its own independent identity, let's call it Channel 4, to manage the traffic between 3 different bosses. It needs to be a neutral hub.
That makes sense. It's like, if I'm working for just you, I'm your assistant. But if I'm working for 3 different people, I need to be the office manager. I need my own title to maintain authority and not get confused.
That is perfect analogy. You are no longer a subordinate. You are a service provider. The EWM becomes a service provider to multiple clients, so it needs its own business card, its own identity.
And there's one more little detail about the business system group that's crucial. The checkbox.
Ah, yes. The SAP indicator. A tiny little box with huge implications.
Correct.
When you are configuring this, deep in the settings, there's a literal tick box. If you tick it, you are telling the EWM, this system I'm talking to is an SAP system.
And if you don't?
If you leave it unticked, it assumes it's a non-SAP system.
Which implies that EWM is flexible enough to manage a warehouse for a company that isn't even using SAP for their finances.
It is. And that's a huge selling point. You could have an Oracle finance system, or Microsoft Dynamics, or even some homegrown mainframe from the 1980s that runs on green screens. As long as you can format the data correctly and send it over, the BSG allows EWM to talk to it. It acts as a universal translator.
That's pretty powerful. It's not a closed ecosystem then.
Not at all. It's designed to be the logistics hub, regardless of what the financial brain looks like.
So that's the identity piece. We know who is talking. Now we need to look at the architecture of where these systems live. This is the shift from the old world of decentralized to the shiny new object, embedded EWM.
The new world, or at least that's what the marketing brochure says.
The source material has this diagram. It shows a single server box, a CPU symbol, and inside this box you have the ERP, now called S4HN, and the EWM sitting right next to each other.
That diagram is seductive. It implies simplicity. It looks clean, unified.
It really does. And I think the intuitive question, the question every CIO asks when they sign the check is, if they are in the same box, running on the same server, sharing the same database, do they just telepathically know what the other is thinking? Do we just skip all the connectivity?
And the answer, which usually frustrates people, is no. A hard no.
Why not? They're roommates. They share a kitchen.
They are roommates, but they have deep-seated trust issues. You have to remember the history. EWM was born as a decentralized product. It was designed to live on its own server as part of the SAP Supply Chain Management, or SCM, box.
So it was built to be an island.
Exactly. It was architected to be suspicious of the outside world. All communication was formal, structured, and went through very specific channels. When SAP decided to bring it in-house and embed it into S/4HANA, they didn't rewrite the entire code base from scratch to merge it with the ERP.
That would have been a massive undertaking.
It would have taken a decade and probably introduced a billion bugs. So they essentially lifted and shifted the existing EWM architecture inside the ERP box.
So the software still thinks it's separate.
It does. It suffers from an identity crisis. It still requires an internal bridge to talk to the ERP, even though they are technically sitting on the same hard drive. If you don't build that bridge, the EWM will sit there in silence, unaware that the ERP is right next to it.
This leads us to the logical system split. In the standard SAP world, usually one client equals one logical system.
Right. A client in SAP is essentially a self-contained business environment. Usually that environment has one logical name. If I am logged into Client 800, the system's logical name is, let's say, S4HCLNT 800. Simple.
But in embedded EWM, the source says we need two logical systems for one client.
Yes. This is the core of the paradox. The main logical system, which represents the ERP side. So that's our S4HCLNT800. But then you need a second one, the dummy logical system.
The dummy logical system. For example, EWM CLNT800. I have to say, I love that they call it dummy. It feels like the developers were just frustrated.
It's not meant to be derogatory, though it is funny. It's functional. Think of it this way. Imagine a large corporate building. That's your server, your client. On the fourth floor, you have the administration department. That's your ERP. On the fifth floor, you have the warehouse department. That's your EWM.
Same building, same street address.
Same building. But the administration department can't just yell through the floor to the warehouse department to send an order. There are different entities with different functions. They need to send a formal memo to communicate.
And to send a memo, you need a distinct address, an inter-office mail code.
Exactly. The main logical system is the signature of the admin team. The dummy logical system is the signature of the warehouse team. Even though they're in the same building, they need those unique signatures to route the memos, the data internally.
And what happens if you don't have it? If you just had the one logical system?
The ERP would try to send the data to itself. It would be like mailing a letter to your own address. The system would get confused, and the message would die in a loop or just error out. It wouldn't know how to hand it off to the EWM functionality.
So the dummy system is basically a mask that the EWM wears, so the ERP recognizes it as a distinct entity to talk to.
Precisely. We are tricking the software into working. We are simulating distance to satisfy the code's anxiety about talking to strangers.
That is surprisingly philosophical for a logistics conversation. It's like we are managing the psychology of the software.
It's engineering pragmatism. It's the cleanest way to make the old code work in the new environment without breaking everything. It works, so we do it.
So we have the identities set up. We have the traffic cop, BSG, and the roommates, logical systems. Now we need to actually run the cables, the invisible wiring. This is where we get into RFC destinations.
RFC stands for Remote Function Call. It's the standard SAP phone line between systems. It's how ABAP systems have talked to each other for decades.
And again, the surprise here is that even in the embedded same box scenario, you still need to set up these remote phone lines. It feels counterintuitive.
It does. It follows the same logic as the dummy system. Because the code is expecting to make a remote call, you have to give it a remote destination to call, even if that destination is just, a different room in the same house.
So you're setting up a phone call to the person sitting next to you.
You are. You need a specific pipe defined from the ERP to the EWM and another pipe from the EWM back to the ERP.
Yeah.
It has to be bidirectional. The warehouse needs to be able to confirm things back to the ERP like, yes, I received that pallet.
Now, here is a detail that I think is a huge quality of life improvement for anyone who has managed these systems. In the old decentralized days, you had to maintain separate user IDs for this data transfer, right?
Oh, it was a headache.
Yeah.
You had system users or communication users, things like Alera Moat or WF Batch. Every time data moved, it was technically moved by this generic system ID.
So if I looked at the logs to see who moved a pallet, what would I see?
You would just see the system did it.
The system moved the pallet,
Yeah.
which is completely useless for auditing.
Exactly. Who made this mistake? The system made it. You lost the chain of custody. Plus, you had managed passwords for these generic users. They would expire. The interface would crash at 2 in the morning. It was a constant maintenance task.
But in embedded EWM, the source highlights the current user setting.
This is the beauty of sharing the same box. You can check a box in the RFC destination that says current user.
What does that mean practically?
It means if you, the host, are logged in with your personal ID and you trigger a warehouse task, say you create a sales order that needs picking, the system uses your ID to send that data across the internal bridge. It doesn't need to switch to a generic system user.
So if there are 20 people working in the warehouse, the system is using their 20 individual IDs for the transfer seamlessly.
Exactly. It streamlines security and it makes the audit trail crystal clear. You know exactly who did what and at what time. It seems small, but for a security administrator or an auditor, it's a gift from heaven.
That is nice. But of course, it's not all just checking boxes. There is some deep technical wizardry required to set this up initially. The source walks through a few transaction codes that sound like secret handshakes.
The one-time fixes, these are critical. If you miss these, the brain is there, but the synapses aren't firing. You have a very expensive, very quiet piece of software.
First up is transaction BD97.
BD97. This is where you formally introduce the parent to the child. You go in there and you assign the main logical system, the ERP, as the standard backend for the dummy logical system.
So you're creating a hierarchy.
You are. You're telling the system, hey, if you see a standard call or a dialogue call for this dummy system, route it here. It's like setting up mail forwarding within the building. All mail for the warehouse department goes via the admin department's main desk.
And without that, what happens?
Without this, the dummy system is like a child lost in a supermarket.
Okay.
It has data, but it doesn't know where to take it. It doesn't know who its parent is.
Then there's this mysterious program. The source was very specific about this. Transaction SC38, which is the program editor, and then you have to run a report that starts with SLSCWM.
Right. It's usually something like RERP dot or a similar name.
Mhm.
The naming convention is key here. SL for supply chain, WM for warehouse management. This program is a mandatory initialization step.
What does it actually do? The source was a bit vague, just said it prepares the environment.
It's the big red button. It effectively flips a few thousand internal switches in the database that you can't access through normal menus. It creates the necessary linkages, populates tables, and sets parameters that say, okay, we are now operating in an embedded environment. It's a run once and never touch again kind of deal.
So if a company is doing a new implementation and they forget to run this program,
Nothing works. They'll spend weeks troubleshooting RSC connections and logical systems. And the problem is they just forgot to press the on switch for the whole environment.
and then the final check. How do you know if you did it right? The source points us to SE11, the data dictionary.
Right, you go into the technical guts
Mhm.
and you check the table TBLSDEST. Stands for Table Systems Destinations.
And what are we looking for? A green light.
Pretty much.
Oh.
You are looking for two specific entries. You need to see the entry for your ERP to EWM connection and your EWM to ERP connection sitting in that table. If those rows are there, you know the internal wiring is active. The circuit is complete.
I like that. It's like checking the fuse box to make sure the breakers are on.
Exactly. If that table is empty, the lights aren't coming on no matter how hard you click the mouse.
Speaking of turning things on, let's talk about the cable package. Because apparently, just buying S4HANA doesn't mean you actually have EWM turned on.
This is a classic trap for new players. The source uses a great analogy, the set-top box.
Yeah, I loved this. You buy the set-top box, the hardware, but that doesn't mean you can watch the sports channel. You have to subscribe, or in this case, activate it.
In the SAP world, we use the switch framework, transaction SFW5. This is where you manage all the optional functionalities in the system.
SFW5. And we are looking for the sports package, which is technically called log integration.
Logly integration, logistics execution integration. This is the enterprise business function that actually enables the integration between the ERP side of logistics and the extended warehouse management side.
The source describes a light bulb interface.
It's very visual. In the transaction SFW5, you see a list of thousands of functions. Next to them is a light bulb icon. If the light bulb is lit and blinking, the feature is active. If it's off, the code is there, sitting on your server, but it's dormant. It won't do anything.
And this applies to both decentralized and embedded setups. This isn't just an embedded thing.
It does. But it's especially critical in what we call greenfield implementations.
Greenfield meaning a brand new company starting from scratch.
Exactly. If you're a brownfield implementation, meaning you're upgrading an old system, that switch might already be on from your old ECC system. But if you're a greenfield, you walk in, the system is fresh out of the box and everything is turned off by default. You have to work with the basis consultants to physically flip these switches.
And there was a warning in the source material about this. Activate only required business functions.
This is a dangerous place. Some switches are reversible. You can turn them on, realize you don't need them, and turn them off. But others, including some of these logistic switches, are one-way streets.
Irreversible. You can't undo it.
Yes. Once you turn them on, the system executes scripts that alter the database structure. It adds columns, it changes data types, it rewires fundamental processes. You cannot just unclick that. You can't put the toothpaste back in the tube.
So if you act impulsively, you could permanently clutter your system with features you don't need.
Or worse, introduce conflicts with other functions you might want to activate later. You have to measure twice and cut once here. It's good advice for software and for life, generally. Don't just flip switches if you don't know what they connect to.
Words to live by. So we've got the identity, PSG, the wiring, RFCs, and the activation, SFW5. The body is built, the brain is connected. Now we need the lifeblood. We need data.
The plumbing is installed. Now we need to turn on the water. Connectivity is useless without content.
The source breaks this down into 3 pillars of business data: Org structure, master data, and transactional data.
Right. Org structure is the where, the physical layout, plants, storage locations, the warehouse aisles, the bins on the shelves. It's the static blueprint of your business.
Master data is the what?
The nouns, materials, vendors, customers, employees, the entities that you do business with or about.
And transactional data is the how.
The verbs, purchase orders, transfer orders, goods receipts, sales orders. It's the data that represents movement and action.
I want to zoom in on master data because the source shared a specific anecdote about Suzuki cars that really clarified why this is so complex and so critical.
The Maruti Suzuki example, it addresses the fundamental question, is master data fixed? And many people think it is. You set up your products and you're done.
And the answer is a resounding no.
Think about the car manufacturer. They build a warehouse. That's the org structure, the walls, the bins, the docks. That doesn't change often. Maybe once every 10 years you build an extension, but the stuff inside.
The source used the example of the Suzuki Swift. They sell the car. It has a material number. The next year, they introduce a variant, the VI or the ZI.
Right. It's 90% the same car. It looks almost identical. But to the system, it is a completely new noun. It has a new material number.
Why? Why not just call it a Swift?
Well, maybe the VI model has alloy wheels and the base model doesn't. Maybe the ZI has a different stereo. So the bill of materials is different, the cost is different, the sales price is different. Therefore, it has to be a new material.
So the noun has changed.
Exactly. A new material code is born. A new price is attached. That is new master data. Even though the factory building hasn't changed at all, the things flowing through it are constantly evolving. Every day, the ERP creates new materials, new vendors, new customers.
And the warehouse needs to know about them immediately. If a truck shows up with the new VXI model and the warehouse system doesn't have that code,
The receiving clerk is stuck. They literally cannot scan the box. The system says unknown item. The truck sits at the dock, blocking traffic, costing money, and the whole supply chain backs up.
so we need a mechanism to keep the warehouse perfectly synchronized with the ERP. And this is where the old world versus new world divide gets really sharp.
It does. In the old world decentralized EWM, we used CIF, the core interface.
CIF, the source describes it as a unidirectional flow for master data.
Unidirectional meaning one way, and it's critical that it's one way.
Why only one way?
Because the ERP is the source of truth for master data. You don't create a vendor in the warehouse software. You don't create a new product on the warehouse floor. You create the vendor in the finance ERP system, and then you push that information down to the warehouse.
And the process for CIF seemed a bit clunky. The source mentioned 2 steps.
It is clunky. It's a batch process. Step 1, create an integration model. This is where you go in and select the data you want to send. Say, I want to send all material codes starting with A for this specific plant.
So you're building a package of data.
You're building the package. Step 2, activate the integration model. That's the trigger that actually pushes the data across the wire to the EWM system. If you create the model but forget to activate it, nothing moves.
And there is latency, right? There's a delay.
Always. You create the new car part at 9:00 a.m. in the ERP. The CIF batch job is scheduled to run every 15 minutes, so it runs at 9:05 a.m. If the truck with that new part arrives at 9:10 a.m., you have a problem.
Okay, so that's the old world. Create, activate, push, and hope the timing works out. Now, what happens in embedded EWM? The source was very explicit about this.
In embedded EWM, for this kind of math, you don't set up integration models for materials or vendors anymore.
So how does a warehouse know about the new Suzuki variant? Does it just guess?
It cheats. Because they're in the same box, sharing the same database, the embedded EWM uses internal direct read functionalities.
Direct read, what does that mean?
When you scan a product in the warehouse, the system effectively peeks over the wall into the ERP database tables and says, hey, do we know this guy? It reads the ERP's mind in real time.
So there is no duplication of data. You don't have a copy of the material master in the EWM side.
Minimal. There's still some warehouse-specific data that gets added, but the core data, the description, the unit of measure, is read directly from the ERP tables. And because of that, there is zero latency.
Zero.
If the ERP user hits save on the new part at 9.000.01, the warehouse scanner knows about it at 9.00.02. It removes that layer of duplication and the delay of pushing data through an interface.
That sounds vastly more efficient and less prone to error.
It is. It's cleaner, it's faster, but it creates a dependency. In the old days, if the ERP went down for maintenance for an hour, the warehouse had its own copy of the data. It could keep receiving and picking for a while as long as it wasn't a brand new product. Now, they live and die together.
Uh,
If the ERP database locks up or the server needs a reboot, the warehouse cannot verify the data. Everything stops.
that ties back perfectly to the roommates analogy. You
Right.
don't need to mail a letter, CIF, to your roommate. You just shout across the room. But if the power goes out in the apartment, you are both in the dark.
Exactly. It's a trade-off between real-time efficiency and system resilience.
Even better. Before we wrap up, the source touched briefly on the cloud. Everyone is talking about cloud these days. What does that mean in this specific SAP EWM context?
It's important to clarify because cloud is a buzzword that confuses people. In this context, it primarily refers to ownership and infrastructure management.
So it's not about the features changing.
Not really.
Yeah.
If you are on-premise, you own the server box. It's in your data center in your basement. You are responsible for the cooling, the electricity, the backups, and the guy who comes to fix it when it smokes.
And cloud.
In the cloud, SAP or another provider like Azure or AWS owns the box. They provide the database, the servers, the maintenance, the patching. You're renting the infrastructure.
And for the user, what's the difference?
For the user, the experience shifts from a desktop application, the SAP Logon Pad, to a web browser. You log in via a URL in Chrome or Edge, just like you log into your email. The functionality is the same. The BSGs, the RFCs, the dummy logical systems are all still there in the background. But the access point and the back-end responsibility have shifted.
So the plumbing is the same. It's just in someone else's house.
That's a great way to put it.
So we've covered a lot of ground. We've gone from traffic cops to internal wiring to sports packages. If we step back and look at the so what here, what is the big takeaway for our listener?
I think the big takeaway is that simplification is actually incredibly complicated to engineer. We moved from separate systems to one box to simplify the IT landscape. Embedded sounds simple. But as we saw, embedded is a bit of an illusion. To make it work, we had to build this labyrinth of mirrors. We had to build a dummy system. We had to trick the software into thinking it was still separate.
It's like we built a modern house but had to keep the vintage wiring because the old appliances wouldn't work without it.
Exactly. The dummy logical system isn't dumb at all. It's the essential bridge between the legacy architecture of the past and the high-speed capability of S/4HANA in the future. Without that dummy system, the whole thing breaks. It's a testament to pragmatic engineering over theoretical purity.
And it highlights that you can't just install software and expect it to work. You have to understand the history of the software to configure it correctly today. You're dealing with decades of design decisions.
Precisely. You are configuring the ghost of the old system inside the body of the new one. And if you don't respect the ghost, it will haunt you with errors and system failures.
I want to leave the listener with a thought based on that Suzuki example. We talked about how master data, the car variants, changes constantly, but the org structure, the warehouse building, stays the same for years.
Right. The digital changes fast, the physical changes slow.
Here's my question. At what point does the complexity of the data outweigh the reality of the physical warehouse? If we are creating thousands of new variants and new master data points every year, but our physical shelves aren't moving, does the software eventually become too smart for the building?
That is the ultimate constraint. That's a fantastic question. We are reaching a point where the digital resolution of our supply chain, our ability to track every tiny variant, might outpace our physical capacity to handle it.
You mean the software knows more than the building can hold?
Yes. The software says, put this VXI model in bin A and the ZXI model in bin B. But if bin A and bin B are overflowing because the building hasn't grown, the software can't save you. The most elegant code in the world can't create more physical space.
The brain is firing perfectly, but the hand is just too full to grab anything else?
Exactly. The constraint shifts from the digital to the physical, and no amount of dummy logical systems or real-time data integration can fix a full warehouse. The system becomes a perfect record of a physical failure.
Something to mull over next time you look at a warehouse and think it's just a dumb building? It's actually the limiting factor for the super brain we just described.
Indeed, it's the ultimate reality check.
Thank you for unpacking this with us. Check your connections, make sure your SAP indicator is ticked, and we'll see you on the next deep dive.
Goodbye, everyone.